Excellent. So now chapter 6, virtual storage. After this chapter, we'll be halfway through the first set of the two major courses that we're doing. This one's all about storage. Data store is what VMware uses as the logical storage unit. This can be quite a number of things, from their own format of VMFS to NFS to vSAN and vSphere virtual volumes. All of our servers need to have a place to store these virtual machines, to call upon them, to manipulate and manage them. That is where our storage comes into play. And this could be done in quite a number of ways. You could either directly attach hard drives and format them into VMFS. You could use things like fiber over Ethernet, iSCSI. You could connect a NAS storage device. You could do vSAN or the vSphere virtual volumes. You have quite the number of ways to interconnect a storage, either physical drives all the way up to storage servers, to use as storage for VMware. You have some capabilities. Of course, the vSphere vMotion support, made by them, has the most capabilities. For example, it's the one that can connect on pretty much anything. VMFS is the format that you will see most commonly, especially in small setups. This allows dynamic expansion of the drive, so quote. It can handle different block size. It can handle quite a lot of movement between the files that live in the file system. So think of VMFS like NTFS or FAT32 or XFS or APFS. It's another file system, or ButterFS. They're all file systems, and VMware has their own. You can also use NFS if you have a NAS device like a Synology or any other products. You can connect those to VMware and provide storage for your infrastructure. vSAN is this very interesting concept that they made of taking SSDs and hard drives together to create this vSAN data store, which we'll cover a little later. It's interesting. And then there's also virtual volumes that are not necessarily LUNs like in other setups, but they can be complete systems that are acting as virtual volumes. Just as with a virtual machine running locally on your laptop or desktop, it is possible to map a physical drive as a virtual drive. It's not necessarily a good thing if we're talking in a much bigger data center infrastructure. It's better to join those physical hard drives together, but it is possible in case you need it, like if you're doing forensics. Anything physical, just like with networking, you have to consider the physical limitations. how much data can come in and out, how much disk caching exists, any possible issues with any other bottlenecks. You have to think about all these things as you figure out which storage method to use. Fiber is one of your many options. It could do, ESXi can support up to 32 gigabits per second fiber channel or fiber channel over Ethernet, if you so happen to have a fiber channel on your backbone. So we have our disk arrays of physical disks. They'll be connected to logical unit numbers or LUNs. Those will have their own storage processors connected through the physical fiber out to the hosts that will run the VMs. We're talking high speed interconnectivity, but we need it if we're dealing with critical systems and they need access to storage very fast. To address them, there are a number of ways that exist. So those ports would be like the WWN. You can define what zone, if we have many disk arrays into various LUNs, we can divide that out. So we can have different VMs working off of different zones, which is great if we're managing our systems infrastructure wide. Multipathing also exists so that if and when, because it's not really an if, it's always a when hardware dies, we can have a failover so that our communications continue regardless that switch A's port died or the entire switch collapsed. Especially with this level of infrastructure, we want to ensure that it's on all the time. Fiber channel over Ethernet has a little different setup. You can either do it software-based or hardware-based. Either way, you'll need the physical fiber channel over Ethernet switch to connect out to either the rest of the LAN, where our workstations and endpoint devices will be, or to a SAN, if we so happen to have a SAN infrastructure in our data center. If we're going to use software fiber channel over Ethernet, you can make a virtual switch to handle that and define a specific NIC card that will connect out to that physical switch. A note that if you're going this way, you can select up to 4 network adapters to use in this method. Once you have that physical or the virtual, switch set up, then you can go and configure it as a software fiber over Ethernet. You can do multipathing. You'll just need to define which cards you're going to be using, defining their information, and inputting that into the virtual switch settings. iSCSI is just another way of connecting our physical hard drives in a SAN or in a NAS out to our infrastructure. And just the same, those disks will be in LUNs. They'll have their own storage processors connected through a TCP/IP network that'll connect out to our hosts, our ESXi hosts. iSCSI works a little different. You have a different target name, an alias, but you'll have an IP address attached to them. That information will need to be added into ESXi or into vCenter in order for them to see it, to see these these iSCSI devices. Now you have three ways of connecting iSCSI. It could be an independent hardware, it could be a dependent hardware, or software. All depending on what hardware do you have in your data center. Setting it up, you'll need either the software or the hardware adapter, of course. You'll need to create a port that will be specific for iSCSI. This same port will work for any NAS or NFS storage. So the beginning steps will be the same. Ideally, you want anything storage related to go out of its own card. You really don't want to mix the storage communication with like your management or your main network. That's not a good idea, especially because your storage communication is essential. I mean, can you imagine ripping out a hard drive while it's on a computer? That's pretty much what you'd be doing if you have any network failure on your storage side. So just like FCOE, there is the place for iSCSI. You'll need to find the connection and IP address of that iSCSI storage system. It could either by static or dynamic, and it'll be entered into the list of targets. If you have a CHAP configuration for authentication, you can set that up. By default, it's off, but if your iSCSI device has CHAP authentication, you can enable that there. Just as with the others, you can do multipathing in case one NIC card dies and you need to get out. You need to continue communication. It is possible to do so. A little deeper dive into VMFS, the file format or the file system that you'll see installed in an EXXI system. It can handle volumes up to 64 terabytes of size. It is the default for everything VMware, as you can see in this long list here. When you attach a data store, like a physical drive, it'll get formatted into VMFS, and you'll be able to see it on the side over here, the format type that it's in. By going into the storage section and click it on the data store, you'll be able to see the files that exist. So every VM will have its own folder, and within there will be all the files. This is your default configuration for VMFS. It is possible to overcommit storage, so be careful with that, especially as you're using thin provisioned VMs and you're using a lot of them. Keep that in mind. You can over allocate. You can increase the size of a VMFS data store by either adding more disks or adding another LUN to it. One big point is you can expand, but you can't shrink. So once you grow a VMFS data store, you can't go backwards. You can only go forwards. These are also able to be deleted or unmounted as needed. Just by right-clicking on that data store, you can see these options. These multipathing algorithms, again, come into play, especially because we're talking about infrastructure that people are going to depend on to be on all the time. So having multipathing is essential at this stage. We can configure scalability and availability within the XSI to allow multipathing and saying how do we want to get how do we want to keep our connections on. NFS, which tends to show up in NAS systems, are also able to connect to ESXi and be used. You'll need at least version 3 or 4.1. It'll need the IP address, it'll need a folder where it's connected to, and the host that'll be mounted. Again, you want to divide out any NFS network separate from other network like iSCSI. You'll be able to define what version we're connecting. And here you kind of see the difference between the two. One key difference is with 4.1, it can't handle storage DRS and site recovery, but 3 does. When adding an NFS, like I said earlier, you'll give it a name. You need to define what folder it will be mounted. Well, what folder we're using in the NFS system. If we're using any authentication like Kerberos, you'll need to add that information in so that it can connect. Then you can define how you'll be connecting. Once it's available, you'll be able to see something like this. Here's my NFS data store that's already mounted. It's a 4.1. That's the URL to it. And as always, you can right-click and unmount when needed. Just as with the others, we can define a multipath because we want to keep our connection to our storage devices on up at all times. For NFS, you can use either the cross stack or not cross stack. You can kind of see your recommended configurations for that. It is possible to do session trunking with NFS 4.1. So again, we have multipath. We can either connect to 10.10 or 10.20 to get to that NFS storage. vSAN, like I said, is an interesting concept, interesting implementation by VMware, using multiple disks in an interesting array. So to do vSAN, we have our server. We need to have at least one NIC card that's either 1 GB or 10 GB or gigabit, excuse me. We need to have a controller, either a SAS or SATA controller. We need to have an SSD and at least one other drive. One SSD will function as the cache. Everything else will function as the data. The idea being, we have our data on these slower drives. Anything that vSAN thinks is going to be used will be cached so that it gets out the door faster. To enable vSAN, there is an option within vCenter. Give it a name and say, yes, this is a new cluster vSAN that we're making. Again, we'll have different disk groups together, one acting as our cache and the rest being our disks, and we can have up to 7 per group. So there in the summary, we'll be able to see our vSAN cluster and how much space we're using. I know that picture is kind of blurry. this might be suitable for your needs. You might need, because you have a lot of spinning disks, but you don't have the budget to buy or to replace them all with SSDs, but you have some. You could make this kind of SSD hybrid situation. So in those groups, you'll have your data store, and those VMs will be able to be saved and moved across all these groups. As always, you can set up policies to manage how the clusters will work together. And here's where you can set up those rules, like which type of storage is provided to the virtual machine, how virtual machines are placed within storage, and what services are offered to the VM itself. We can view the consumption of storage and make any edits as needed. That will be within the VM itself. So we can see in this Linux 01 VM, it's using 4 gigabytes of disk storage on the data store. 1.3 gigabytes up with 8 coming back down. Any questions? I know that was kind of a lot. But it does cover the various ways that you can connect storage to your infrastructure, whether that's either Fibre Channel, a vSAN, NFS, iSCSI, or the native VMFS. Cool. If there are no other questions, then I will stop the stream.